So if we're trying to turn it into an explicit formula, we have to start thinking about the patterns here and what they mean in terms of operations that we can do. Operations meaning add, subtract, multiply, divide, all of those. So repeated multiplication is something that happens when we're talking about exponents, right? If you're multiplying 2 by itself a bunch of times, or multiplying by 2 a bunch of times every single time, we're talking about something 2 to the power of something. So if I were to look at this as a table, as I've done already, you can think about these numbers as being raised to that nth term, right? So 2 to the first power is 2. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. Notice that pattern that is happening, and it is happening in this diagram here, or in this table here. It's just not happening quite in the way that we think it's going to be happening, because our nth term is really 2, not to the power of n, but to the n minus 1, right? Our second term is 2 to the power of 1. Our third power is 2 to the power of 2. Our fourth power is 2 to the power of 3. So that's how you do the explicit form. That's the difference between recursive and explicit. Next pattern, we have these triangles here, and we're adding by one more every time. So we've got 1, our first term is 1, our second term is 3, our third term is 6, and so on. I'm sure we can see the recursive formula here where you take the previous one and you add on one more than you did before. Here, if we turn this into a table, just kind of squeeze it in here. Our first term is 1. Our second term, though, we take the previous number and now we add 2. Our third term is we take the previous number and now we add 3. Our fourth term is we take the previous number and now we add 4. So the recursive formula here, R for recursive, is that you take the previous term and you add in what term number it is, right? So in our fifth term, we're adding in 5. In our sixth term, we're adding in 6. Versus our explicit term, so this guy is 10, this guy is 15, and this guy is going to be 21. It looks like I could spend time here and talk about how to turning it into an explicit form, but this is kind of the idea of what we're doing, and you can see it below here as well. We've got a ton of terms. I don't want to spend too much time on this because we're going to run out of time to finish this lesson today. So we get the general idea, recursive versus explicit. There's 2 different types, and now we're going to go on to our examples. We're told that the first 5 terms, we're told to find the first 5 terms and the 50th term of the sequence. Here it says b sub n. So instead of x, it's b. It still means the same thing. B sub 1 is the first term. B sub 2 is the second term. And here we're given an explicit formula, so it's easy to find all of those things. The first 5 terms, I might make a table here to answer this question. 1, 2, 3, 4, 5, and I'm going to do ... and 50. So b sub 1, I plug it into the formula. 2 minus 1 over 1. So that is 1. Okay, 2, so it's going to be 2 minus a half, so 3 halves. Term number 3 is 2 minus a third, so that would be 6 over 3 minus 1 over 3, so that would be 5 over 3. 4 would be 2 minus a fourth, so 8 over 2, no, yeah, 8 over 4 minus 1 over 4, and that would be 7 over 4. Term number 5 is 2 minus 1/5, so 10/5 minus 1/5, and that's 9/5. I hope that by now you've noticed a pattern that your denominator is going to be what the term number is. So I'm going to do 50 here, and then notice that the numerator is the term multiplied by 2 and then minus 1, right? The fifth term, the numerator in the fifth term is 9, which is 5 times 2 minus 1. And so that's going to be 100 minus 1, which is 99. Or you could just plug it into the formula and get the same thing. But that's how you deal with fractions in these types of situations. Okay, we're going to find the first 5 terms and the 20th term of the sequence. It tells us to do it f sub n, given this pattern here to the right. So I'm going to make a table of values. It says f sub 1, f sub 2. I'm going to make it into a table. I don't want to do a recursive formula here, because if I want to find the 20th term, that means I would have to find all 20 of them, and that is ridiculous. Okay. So these are the first 5 terms. I could write them out as numbers. So I'm going to call this n, and then I'll make another part of this table, which is f sub n. So this is 1, 3, 5, 7, 9. And now what we're trying to do is we're trying to find the pattern between n and f sub n. We're trying to boil down the essence of this pattern into just numbers. So how does 1 relate to 1, and then 2 to 3, and then 3 to 5, and 4 to 7? Trying to play around with it. It comes easily for me, to my mind, just because it's a pattern that you tend to see a lot when you're first learning about sequences. So notice if you take n and multiply it by 2 and then subtract by 1, you get that number. That is how you define odd numbers, is that you take any number you want, multiply it by 2, and subtract by 1, guarantees you to give an odd number every single time. So this is n times 2 minus 1. So I'm going to write down my explicit formula. F sub n equals 2 times n minus 1. So in order to find the 20th term, f sub $20, I'm going to do 2 times 20 minus 1, which is 40 minus 1, so 39. Much easier than having to keep counting them up all the way. All right, last problem for today. A 180-liter bathtub contains 50 liters of hot water and is being filled at a rate of 10 liters per minute. How much water is in the bathtub after 5 minutes? I'm going to take this information and turn it into a table. My table is at 0 minutes, so we'll do n, let's do m actually, and then x sub m. At 0 minutes, I have 50 liters. At 1 minute, I have 10 more, so that's 60 liters. At 2 minutes, I have 70 liters. 3, I have 80. 4, I have 90. And at 5 minutes, at the end of 5 minutes, I have 100. So at the end of 5 minutes, I have 100 liters. It says, when will the water flow over the top of the bathtub? It says that the bathtub is 180 liters. And so if it's flowing over that, we are talking about being more than 180. So instead of continuing to count up, which I could, it's in sight, I would have to do it 8 more times. I am going to try and turn this into a formula. So I start with 50, and that's a good way to start your explicit formulas, is that it should be 50 plus something. Now, in order to get from 50 to my first minute, I added 10. But to get from 50 to my second minute, I added 20. 50 to my third minute, I added 30. 50 to my fourth minute, I added 40. Are you starting to see a pattern? So it's going to be 50 plus n times 10. So I start with 50, and after 20 minutes, I do 20 times 10 and add it to my original 50. And that's kind of the pattern we'll see here. There will be a formula. I'm pretty sure it's in your formula packet. You just haven't learned it yet. Okay, so x sub m equals, and I forgot that that's an m, not an n. So 50 plus m times 10, or 10m plus 50, however you'd like to write it. Now, if we're trying to figure out how long until the water flows over the bathtub, we need to set this equal to the capacity of the bathtub, which is 180. So I'm going to subtract 50 from both sides and get 10m equals 130, which means that m equals 13. So 13 minutes is when it will start to overflow. The drain is open when the bathtub contains 50 liters of water. It is still, oh my goodness. It is still being filled at a rate of 10 liters per minute. The water drains out at a rate of 15 liters per minute. How long will it take until the bathtub is empty? Okay, so we've got an adding in of water and a taking out of water. So what is happening is we still have our 10m situation, but every minute we're adding in 10 and taking out 15, which in reality means that we're actually taking out 5 liters per minute. But let's talk about how that's made into an equation. So we start with 50, and every minute we're adding 10, but also every minute we're taking out 15. So we can combine like terms and have a formula that looks like that. How long will it take till the bathtub is empty? So we want to know how many minutes until this guy is 0. I'm going to add 5m to both sides and get that 50 is equal to 5m, and then 10 equals m. So after 10 minutes, the bathtub will be empty. Okay, so that is our entire notes for today. Your homework is pretty simple and straightforward, just doing a lot of this just with numbers. In your daily agenda, I've added a cool couple videos looking at sequences in terms of action photography and looking at how people have done that professionally. I want you to watch it just for fun, but also because you can try and think about how would they try and fix that mathematically. How does that play into this idea of creating an equation to represent patterns as they're shifting across a screen? Okay, great job today, guys. Let me know if you have any questions.